thank you all for coming. And what I'm going to try and do is give you an overview of what we do from the solid research group. So our school has 3 research groups, solid, living and changing. I represent the solid side, so I'm going to try and give you a flavour of largely what we do on the geology and the exploration geology degree schemes. So there's quite a lot of us, various ages, various genders, various different bits of experience. We cover all sorts of different things, from oil and gas to volcanoes to the deep interior of the earth. So all I'm going to try and do here is just give you a sense of what I do and how that feeds into some of the things that you might experience as students. So, as you might tell from my accent, I am Scottish. I'm originally from Glasgow. So I graduated from Glasgow University in the sort of end of the 1980s. And I then left Scotland and I went abroad. I did my PhD in South Africa. So I have a lot of African experience, and a lot of the things that I do are still geared around Africa. But I've also branched out into various other areas of the world. So my main role within the school, in addition to lecturing, because I will teach you, if you come here, you will see me a lot on first year fieldwork. You'll see me for a unit in the second year that we call geological resources, and then you might see me for a unit in the third year called applied mineralogy. And I may also supervise your dissertation, either as a third year or a fourth year student. But the sorts of things that I have worked on over the course of my career, and I still currently do, my PhD, and the thing that got me really, really fired up whenever I was a student, was I got the opportunity to work on precious metals. So I analyse rocks, meteorites, and all sorts of other things for platinum and gold. And it's been quite a cool career. I've enjoyed it at various points along the way. But the sorts of things that I work in is I work on ore deposits, I work on meteorites, I get the chance to occasionally work on diamonds, and I work on impact craters as well. And over the last few years, my students have also had the opportunity to work on some of these things. So, whenever I talk about precious metals or platinum group elements, these are the guys that we're looking at. So we have ruthenium, palladium and rhodium over here, and osmium, iridium, platinum and gold over here. And these, in terms of abundances, are actually some of the rarest elements in the Earth's crust. So the reason for that is that they all have an affinity both for iron and for sulfur. So what happened is when the Earth formed, these guys all got sucked down into the Earth's core, or they're stuck inside the Earth's mantle. And what we see on the surface is really very, very rare. That's why there's so little gold, so little platinum available to us. So part of the stuff that I do is figuring out how this stuff gets from inside the Earth up onto the surface, where we might mine it and exploit it and ultimately turn it into useful things. So when we look inside the Earth, inside the Earth's mantle, all of our precious metals inside the mantle are locked up in little sulfide minerals. And the trouble is, whenever we bring something up from the Earth's mantle up towards the surface, it's been sat at very, very high pressure and temperature down there, and suddenly it's like if you shake up a bottle of Coke and you take the cap off, you suddenly release that pressure and everything changes. And that's what happens to these things. So the only way that we can actually study what's happening to these things in a way where we don't change them is if we look at these little sulfide inclusions inside a crystal that keeps them at high pressure. And that crystal is diamond. So what I'm going to show you here is just a little video of a diamond crystal. We took this up to Edinburgh University. We scanned it on a CT scanner. And what you see here in the red here are the little sulfide inclusions inside the diamond. So if I just let this video roll, what you'll see here is we're rotating the diamond round, and you can see the little sulfides sitting within the diamond. So we break the diamond, and we extract these sulfides, and we analyse these things. So this is a 1 carat stone from the Arapa mine in Botswana. To a jeweller, this is rubbish because it contains all of these inclusions. Okay? To a geologist, to a mineralogist, these are some of the most precious samples that we can have. And I get the opportunity, thankfully, to work with some of these from time to time. The other sorts of things I do is, obviously, if we can get platinum and gold out of the Earth's mantle, get it up into the crust, there are places where we can go out and mine them. So this is the main areas around the world where we actually mine platinum. And the biggest and the most important one is a thing called the Bushveld Complex in South Africa. And that's where I've spent a significant amount of my research career. So when you go platinum mining, historically we used to do that underground. You used to work in a very, very narrow space. You used to send men and equipment down there to drill underground. Probably the new frontier for platinum mining is more like this. We have large open pit mines with very, very large diggers and very, very large dump trucks. This is the way that platinum mining is probably going to go for the next 50 years. And what you're looking at here is what's now called the Mogalakwena mine complex. Mogalakwena in the local African dialect is Valley of the Crocodile. And just a little bit to the west of here, we have the Nile River. Okay, it's not the real Nile River that we see in Egypt, but whenever South Africa was explored by the Boer settlers, they reckon they trekked far enough north to find the source of the Nile. So they decided to call this the Nile River, and it's spelt with a Y instead of an I. But in that river, there are occasionally crocodiles, but you very rarely see them. So what you've got here is 4 very, very big holes. Whenever I first went to this mine complex in 1998, this is where they started, and this was half the size. And they are digging their way progressively further north, making these holes bigger and bigger and bigger. So this is where your platinum is going to come from for the next 25 to 30 years. So I have the opportunity to visit this, I have the opportunity to carry out research there, and I send my students there. So what we've got here is over the last 13 years, we've had 6 different students go out there and spend a summer in South Africa working on these different mine projects. And they've collected samples, brought those samples back, and been able to work with them. And this is just some of the snapshots that we've taken along the way. The last 2 to go there indulged themselves in a bit of what they call ethical lion walking. So they feed the lion, and then you're allowed to walk behind the lion holding its tail. They didn't tell me that they were going to do this. I didn't see the risk assessment form for this. They just did it, and I'm very, very glad they came back alive. But they had a fantastic time doing it. So this, as an experience that these students have, this is something that they look back on as a real highlight over the course of their degree. The other place that I've worked on more recently and that I get to go to from time to time is Greenland. I have been working with the Geological Survey of Denmark and Greenland, and also a bunch of Greenlandic mining companies. And my students have also had the opportunity to go to Greenland. Now, Greenland is a phenomenal country. It's unlike any other place that I've ever been to. It's one of the least densely populated countries in the world. The vast majority of people live in the capital, Nuuk, and there are just simply tiny settlements elsewhere around the coast. Basically, this is Nuuk in the top photograph here. There are roads in Nuuk. You go outside Nuuk, there are no roads. There are no roads anywhere else in Greenland. So the only way that you get around is either on your own 2 legs. If you're on the coast, you might be in a boat, or if you've got a bit more cash to spend, then they might stick you in one of these red Air Greenland choppers, and that's probably some of the most fun that you can have, is flying over a snowbound landscape in one of these things. So I got the opportunity to work in Greenland, and I'm showing you an old photograph here. You can tell that the age of it by the gentleman stood here on the left here. This is a proper 1970s geologist with a proper 1970s moustache. And what you see here is an area of rocks that, whenever they first went there in the late 1970s, we had no idea what the heck this stuff was. And I've picked out a quote here from the mapping report that came here. It says, a large area between the Norite Belt and the Tassiarsiac tonalite complex consists of a hitherto unexplained porridge of agmatized rock. right? Porridge was simply the best word that they could come up with to explain this enormous mass of broken up and smashed up rock. We now think we've got an idea what this stuff is. So this belt where the man with the moustache was standing, basically you can follow it in an arc for over 100 kilometres around this part of Greenland. Now, sitting at the centre of it, there is an enormous mass of even more pulverised rock that we call the Finnfjeld domain, and that's shown in this area here. And we now think that what these rocks represent is the world's oldest and potentially largest impact crater. It's a structure that's 3 billion years old, and it's where something very, very large from space slammed into this part of Greenland early in Earth history. And the reason that we have a Carlsberg badge at the bottom of one of these is that if you're Danish, you can apply to a thing called the Carlsberg Foundation. So the Carlsberg Foundation takes a levy on every can or bottle of Carlsberg beer that's sold, and it puts it in a fund for the Danish science and the arts. So my colleague Adam Gard, who is Danish, applied to the Carlsberg Foundation, and the Carlsberg Foundation gave us enough money to spend a summer camping, supported by helicopters, and then the next summer to hire a boat. So all of these little blue lines you can see here were us sailing up and down these fjords to try and investigate what was going on there, all courtesy of the Carlsberg Foundation. So that's a nod to our sponsor there. So as we say, if you're familiar with Carlsberg's old slogan, we would say Maniitsoq is probably the Earth's oldest and largest impact crater. And in addition to this, we've had associations with Greenlandic mining companies since 2008. And on average, we've sent 2 exploration students to Greenland to work with these mining companies on placement projects every year. Covering a variety of things from nickel to diamonds to platinum, all sorts of things. So we still do this, and hopefully we'll have 2 students going to Greenland again this summer. And this ultimately feeds into what you guys are going to be doing if you come here. One of the key things that we want you to take from your time at Cardiff is that we're going to teach you in the field. The field is a natural laboratory, and it's a central part of the things that we do. So these are photographs of students on the final field course that they go to. We take you to the island of Cyprus, look at the rocks, and try and understand the evolution of the island. Now there's one final thing I want to address, and it's a particular problem that we have on geology and exploration, is that historically we have had a gender imbalance. Okay? And that goes back to the time whenever I was a student. In the mid-80s, probably the number of female students on any given geology degree was probably 10 or 15%. I reckon there was 13% female students. There were 4 of them out of 30 in my graduating class. We were very, very male, and we were very, very white as a profession. Now, this is a slightly more modern. This picture was taken 2 years ago. This is a first-year cohort. There's a lot more girls there. Typically, we're now looking at anywhere between 25 and 30%. So that's better, but there's still a way to go. There is nothing to stop women succeeding in the geosciences. In fact, some of the best students that I've taught over the years have been girls, and many of them have been an absolute pleasure to teach. And the way that we're trying to get round this and encourage and support female students, particularly, but also to our male students, is we've introduced a mentorship scheme on the exploration degree. So what we do with that is once you reach your 2nd and your 3rd year, we team you up with a mentor. Someone who is an ex-Cardiff graduate, graduated in the last 10 years or so, who is there to provide you with support and advice in addition to us as academic staff. So they give you a perspective that we can't give you. And in the case of female students, we team you up with some of our most successful female graduates to give you their experience of what they experienced as students and how they've succeeded. So ultimately what we want you guys to do is be able to turn take your sons and your daughters turn them from a first year, an irresponsible first year like this, into a fine, upstanding member of a professional body and of the community. So that's ultimately what we're aiming to do, and hopefully we succeed more often than we fail. So I'll shut up. Thank you very much.